Hey, we're back. It's AASLR again. I'm here with Carrie Roberts, who is back for more. She's got a lot more to share. She has so much stuff to share.
So much. Yep, I'm excited to talk about Atomic Red Team and Defense Evasion. Are we ready to
I'm
go?
also here with my cat and the dog, and they might make a cameo. They're going crazy right now. But before they hit the wrong buttons, I'm going to hand it off to Carrie. Bring your screen up. Here it is. It's all you. Go for it.
There we go. Today we get to talk about Atomic Red Team. We get to talk about Defense Evasion, proxying execution through Rundll32. And we have some fun Defense Evasion stuff to talk about. So first, we're going to start out on the MITRE attack website, looking at technique 1218, system binary proxy execution. So that means using a built-in Microsoft system binary, so something provided for the system to run from Microsoft, installed on Windows by default. Some of those can be used to proxy execution of other code, and the reason why you would do this is for defense evasion because sometimes there may be application whitelisting enabled in an environment that only allows certain executables to run. So if you're an attacker and you want your code to run, but it's being blocked by that application whitelisting, then you could proxy your execution through a trusted executable, because in probably every environment, Rundll32, for example, is allowed to run because a lot of things would break if it doesn't. So we're going to look at that today. This technique has multiple sub-techniques. So there's lots of binaries that can be used to proxy execution. And if we look at this list here, in MITRE, they've defined, 14 sub-techniques. So they have a sub-technique for using compiled HTML files to proxy execution all the way down through MSHTA and regserve32. Today we're looking at sub-technique number 11, Rundll32. So we want to look at all the different ways that attackers are actually proxying their code to run through Rundll32 so that it doesn't get blocked, and also because defenders are more likely to overlook something run by Rundll32 because it runs so many different things and a lot of weird stuff too. So seeing something weird coming from Rundll32 doesn't really raise as many flags as, say, your own, the hacker's own unsigned executable. So for this, in order to actually get down to testing our systems to find out if we detect or block this type of execution, we need some procedures to run. And for that, we're going to jump over to another project called Atomic Red Team. Here, we're looking at that here. It's a free and open source project that has scripted cyber attacks for all of the MITRE attack techniques. So all we have to do is jump into this atomics folder, and in here we see technique numbers, and we can go down to T12, 18, 11, and we can click on the markdown file and we can see everything that Atomic Red Team has scripted for testing execution through Rundll32. We see atomic test number 1 all the way through test 12. So currently there's 12 different ways that Atomic Red Team provides you that you could try to proxy execution through Rundll32 to see if your defenses are adequate. So here we could look at the first one, executing JavaScript using the getObject method. If we read the notes, we find out that this just works in computers that have IE version 8 or lower, and that's super old. So we're going to skip over that today. I don't have IE version 8. We're going to start with atomic test number 2, executing VB script through Rundll32. Since all of these applications are different, all of these tests, we may see that some things are blocked by our AV, which on my system, I just have the default Windows Defender, and some things aren't. So some things are protected out of the box and some things aren't, and that's what we want to test to find out today. So to run this procedure, we just need to run this command from the command prompt. So we have instructions here. We do have this little special variable syntax hashtag squiggly command to execute. That just means we need to substitute what we find in the input arguments up here. In this example, it's just going to launch calc.exe, which isn't malicious executable, but it is a way to proxy that being launched through Rundll32 just as a proof of concept. So we could manually copy this command, put calc.exe here, put it on the command line, but I'm going to use a tool to help us run this library of scripted cyber attacks called Invoke Atomic Red Team. And it just follows the instructions for us and makes it easy to do. So I will say invoke atomic test, and I'll say T1218.011. And for starters, I'll just say, show me the brief details, which is just the title of each atomic test or scripted cyber attack in Atomic Red Team that we could choose to run here. So we see that first one, we're skipping JavaScript with get object, and we're going to start with Rundll32 to run a VB script command. We can say we're interested in test number 2, and before we run it, we could show the details, which is what we just looked at online. We've got a name and a description, and then we have the command here. And here we have calc.exe substituted in. So this is the command that's going to run. We can tell Invoke to run that for us, and in the background, it'll start up command prompt, and it'll run this, and then we can find out if it's blocked or detected. So Rundll32 is a tool that can run a DLL. A DLL is a dynamically linked library. It's a special kind of executable, so it is also an executable like we're used to on Windows, but it's a special kind that advertises different methods, different functions it can provide to other programs. So this MS-HTML is a DLL. It's a DLL that can do things like run HTML applications. So if I'm writing a program and I want my program to run an HTML application, I would prefer not to have to write that code myself. I can use this DLL, MS-HTML.dll, to run the application for me. And then other programs on the computer can also do the same thing. So nobody has to implement that. We can all just use the implementation that's already there in the dynamically linked library. And that's super cool. So this particular test, some malware was seen using it this way before, and that's why it's an example here for us in MITRE attack and also in Atomic Red Team. It's really kind of tricky. You don't normally see the DLL listed like this with VB script : first, and really this is just a trick that the adversary is playing on Windows and how it interprets things. But really, this is going to end up calling MS-HTML.dll and the run HTML application, and it's going to tell the application to start up a shell and run calc.exe using VB script. So let's go ahead and try to run this. So I'll clear this screen. We'll bring that test up. If I erase this, it's going to, if I erase the show details, it'll actually run the test. So in the background, that we're not going to see is a command prompt that's going to come up, and it's going to run that. And then we see this virus and threat protection. Threats found, says exception calling, access denied. That's what happens when in the middle of execution, AV gets involved and says, no, that's not happening. So Windows Defender has decided that a command line of that form with Rundll32, run HTML application, some VB script, etc., isn't legitimate. It's not a normal use case. It's only been seen used by malware, so they decided to block it. So let's go back and look at that again, because we want to play with this a little more. And because we're curious, what exactly is Windows Defender not happy about? Is it Rundll32 ending up spawning calc, or is it just the fact that certain words show up like VB script or run HTML application on the command line? So for this, I'm going to take this command here And I actually am going to run it manually from the command prompt just so we can start experimenting with Windows Defender. So I paste this in here. Let's just make sure it gets blocked again. It does. Access denied. We see Defender pop up and block them. Okay, so then we start playing around and kind of probing Defender to see what is it that it doesn't like. So one thing that we could try, and we can see in one of the later atomics, that some of the DLL functionality, instead of being called by name, so instead of calling a function called run HTML application, they actually call it by number. So functions in the DLL have a name and a number. The number is called the ordinal number. So we could try running this same command, but swap out run HTML application, because our hypothesis is that Defender doesn't like seeing that being called directly like that. And we could change it out for the ordinal number, which we could just Google, or if Google isn't working for us, we could bring up a tool like I have here, Dependency Walker. I have the MS-HTML DLL loaded here, and in this middle window, it shows us ordinal numbers. So some of them aren't assigned to a function. Here, ordinal number 108 does clear phishing data. If we scroll down, we find run HTML application has an ordinal number in the DLL of 135. So we're going to try running this command again, just swapping out run HTML application for 135. And to call a function by its ordinal, you put the number symbol first, so number 135. Okay, and that indeed does pop calc. Windows Defender doesn't have any problems with letting that run. It would probably be better if they also watched for pound 135, since that's a set number, and it means the same thing as run HTML application. So as a Defender, if I want to make sure I'm covered to the greatest extent possible with my defenses, I would want to run both versions of this scripted cyber attack from Atomic Red Team, the one where it calls out the function directly and the one where it uses an ordinal. And since I'm a nice person, I'd also like to make that available to other testers, because other testers may not have tried the ordinal number and feel like they're more protected than they really are. So to do that, we could open up the atomic YAML file. So all atomic tests are defined in this YAML format. So here I have T121811, and this is a hard to read kind of for human format, but we can see everywhere we see one of these dash names is a new atomic test. So here's that first test where we run get object that we skipped. Here's the second test, run DLL32 to execute VB script. So I want to make a new atomic, and as a cheat for that, I can just copy this existing atomic and I put another copy of it here. So here's our second copy, and I will say using ordinal number. And down here, instead of run HTML application, I'm just going to swap out this command for 135. And let's go try it out in our PowerShell session here. Let's list the test again. We should see a new test that we just added. So here we go. We have the original run DLL32 execute VB script, and we have one using an ordinal number. So now we have the scripted, and we can use it to validate our detections week to week and day to day. So I'm going to use a shortcut for the test number -3, test number 3. Let's run that. And it pops calculator just fine. Okay, so I would like this new test to be part of the Atomic Red Team library that other testers can use to test their environment to make sure they're covered against this technique. So I am currently logged in up here to GitHub. GitHub's free to use and free to get an account. So I'm logged in. I'm going to go into this YAML file and under T1218. I'm going to open it up, and I'm going to edit it the same way that I did just locally in my YAML file. So I'm going to click this edit button, and we're actually on the Red Canaries Atomic Red Team project. It's a little misleading because I'm not really editing it like the actual version of it. I'm editing a copy here, and then I'm going to propose that they accept this change. So I'm going to come up here to, we see this test here. I'm going to come right before this test, and I'm going to paste in my test that I just created with the ordinal number to add a new test. Paste that in. Whoops, and then come to the bottom and just say add ordinal version of test to bypass AV. So I'm going to propose these changes. Don't need much more explanation. Down here it shows what I'm adding. I'm just adding this new test with pound 135. And then I create the pull request. So now this goes into a bank of pull requests here. Pull requests, add ordinal test. So it's going to sit here till one of the maintainers of the Atomic Red Team project review it. And if it looks good to them, they will approve it, and it will become part of the library scripted cyber attack. So that's cool. We just added that AV bypass version to Atomic Red Team. Now we're testing it in our environment. Now everybody else can test it and be more aware of these bypass techniques. Let's move on to the next test. Okay, so we're going to look at Rundll32 using advpack is what I call it. I don't know what the designers call it, but let's look at test number 4. So before we run it, let's look at the details of this test. There's some prerequisites where it will download an INF file if we need it, but we already have our prerequisites, so we don't need to look at that. So the actual attack commands are run on the command prompt, and this is what it's going to do. It's going to run Rundll32. It's going to call this shared library advpack. It's going to call a method called launch INF section. And then it's going to load an INF file, which also calls a certain method in the INF file. Okay, let's try to run this one. So we just take off the show details and we run it. And it's blocked. So Windows Defender found a threat and wouldn't let it run. Let's take this same one over to the command prompt and see if we can do the same thing with the ordinal number. So we paste this in. Oh, no, we don't. Ah, pasting is hard. Let's see if I can paste it into here. No. Oh, did 2 different lines too. Okay, that should be it. Take it back to here and call that. And okay, still blocked by virus and threat protection. So let's just see if the same method works. If we look up the ordinal number for launch INF section for this DLL, it is number 35. Hold on. Was it 35? I had a little note here. No, I lost my note. I thought it was 35, but that's not working. Maybe it was 36. Okay, maybe we have to open up advpack because I didn't take very good notes. So and we're going to be looking for launch INF section, launch INF section. There's a few variations here. I think there's even more down here. Launch INF section 38. Oh my goodness. Try one more thing. It should be blocking it if it's working right. Let's try one of these first launch INF sections. I swear this changed. Launch INF section A, 39, 40, and 41. We'll try one more. But it's also not popping up, or it should be popping up Calc or Notepad. What did I say, 39? Okay, so I failed, live demo failure. But it's not popping up our thing, and when I tested before, it still got blocked by AV. So we're gonna have to do something different. So, all right, my idea for doing something different is let's go look at this file, this INF file, and see what it does, and see if there's anything glaring in there that the Defender might be looking for. So I have that INF file open here. So it's got, this weird signature here that it could be looking for that I might want to change. But before I spend too much work trying to change this file, I should just change what's actually being run. Here it's calling another DLL, script object DLL, and it's calling it against a URL. So, whoops. What I did in testing is I took this URL and changed it to something. Let's do something like, I want to copy this first, so go to the end, copy this. Let's do something that doesn't even make sense, but www.google.com, and see if Defender blocks it when we have it set to some other file. This will tell us if Defender's unhappy, maybe with this being called Chicago, which is odd, or the fact that the service name is Atomic Red Team. Maybe Defender's triggering on that. So that's just what we're trying to determine here. So let's go back and run this test again, test number 4, and unrecognized markup, which makes sense because you can't run a script from the Google homepage. But Defender didn't pop up, so that tells me that Defender isn't unhappy with the INF file. It's unhappy with what's in that URL that was there, which I copied. So let's go over to the web and bring that up here and look at that. So here it's an SCT file, and we've got some default descriptions, bandit, just random names that Casey Smith, who came up with this example, sub T, he just put in there because it really doesn't matter. And here it's calling ActiveX WScript shell and then running calc. That's really what should be happening if Defender wasn't blocking it. So if we want to try and play with this file, we could adjust it to maybe take out some of the obvious things, because we may be curious if Defender is triggering on the bandit thing. Maybe this class ID, this is obviously a made up class ID, so we could make up a different one because it could be triggering on that. And through trial and error, I also found that it really doesn't like seeing ActiveX and run on the same line. So let's take this file, and we need to host it somewhere where we can point at it. So for the demo today, we'll just go over to Pastebin and we'll put this in because it will host it for us online. And we'll paste this in, and we're just going to clean it up. There's some extra code here that isn't run. This isn't necessary to take out for what we're doing, but it just makes it cleaner so we can see what we're doing. I'm going to take out all the comments. If you're working to bypass AV, it's a good idea, because many times I've seen AV trigger maybe just on the fact that sub T is in the file, because it's an easy thing for them to do. So we'll get rid of the comments. I'm going to break up this line that runs an active creates and runs an ActiveX object. I'm going to break it up into two lines. Whoops. So here, I moved this down. So now R creates our new ActiveX object, and then we do r.run. So 2 different lines here. I'm going to change this bandit because I'm suspicious that they might be looking for this default value, and also this class ID to switch it up a little bit. So we got that. Okay, looks good. Did I erase my scriptlet tag? Okay, that looks good. We're just going to host this here. It doesn't really matter, but we'll host it for an hour, and then we'll create the paste bin, and we'll get the raw URL to this. So this is what we have. It's our attempt to bypass what Defender's looking at and blocking. So here we have a URL. We go back into our atomic test instead of Google, or instead of the Red Canary URL we had before. We're going to point to paste bin here. And we go back into here and we run test number 4. I knew it. I forgot the scriptlet tag. Okay. Sorry. I got to do this over again. We just need this closing scriptlet tag here. Tried to make it all clean and then I messed it up. Okay. We'll host it for an hour, and then okay, we're changing that INF file that gets called in here. We're running this. Oh my gosh. Okay, dear editor who edits this for live, for the recorded version, don't put this in there. What am I doing wrong? Did I copy the right URL? Yes. Okay, one more time, I swear. Oh, I didn't, here, let's take this. I'm not going to clean it up this time because that's where I messed it up. So I'm just going to put this on another line. Okay, we got r.run. Need semicolon there, and we're going to change these 3 things. 1, 2, 3, 1, 2, 3, and 1, 2, 3, 4. Okay, here we go. This is totally going to work. Okay, thank you. So we got past that, and we learned that AV maybe isn't as wonderful as we thought. I mean, it is great to have, does great things, but it also sometimes isn't super strong in its detection. So it looks like in this case, it was looking for that basic class ID online. It was looking for a bandit in these fields. It was looking for this default made up class ID, and it was looking for these things on the same line, and we were able to get past that. I'm not going to contribute this as a new atomic test because this really just becomes cat and mouse with the AV defenders, where you change this to 1, 2, 3, and then they start looking for 1, 2, 3, and it goes back and forth forever. So in my testing, I just like to switch up the defaults and not publish that, because then the defenders will get in that cat and mouse game with you. So Atomic Red Team lets you set your own variables. So I can say, when you run this test, don't take the default SCT payload from Red Canary's site. Take my version of it, which maybe has some of these things swapped out. And I can make sure that we have strong defenses for this and not based on certain words that are easily changed by the attackers. So one more example we're going to look at. Well, actually, let's look at test number 5. It's very similar. It's just using the IE version of advpack. So if we run this now, it uses the same INF file. So if we run this, it's actually going to work because it's downloading our version from Pastebin that actually pops calc. But if we go back into here and change our INF back to what it used to be, Red Canary, if we change it to this, we'll be back to having it blocked by Defender. And so that was blocked and we didn't pop calc. Cool. Next, we're going to look at the last test on the list, which is test number 13. Let's show the details. So this test, it makes a copy of actually calc, or makes a copy of calc.exe and calls it not an scr.scr. So it's actually an exe, not a SCR file. And then it's going to use rundll32 to call another DLL. It doesn't have the DLL extension, but it is a DLL. It's a control panel item. And it's going to install a screensaver, or call the method to install a screensaver. And it's going to pass to that method this executable that has the SCR extension. That's going to end up making calculator run. So here we are proxying our execution with rundll32 using the desk.cpl DLL. So let's try to run that. And that just works out of the box. So we didn't have to do any tweaks there. Defender isn't unhappy with anything about this particular test. So again, as a defender, we would need to think of ways that we might be able to detect that outside of what AV does. And you might think, well, how could I do that when AV didn't do it? But AV has a much harder job because they need to be sure to not block anything that should legitimately run across every environment in the world. So they have to be more lax with their rules. But in your environment, you can look like, how often does anybody, even install a screensaver using desk.cpl in this way? And then having the rundll32 launch a sub process. So this is probably unusual. So or if there's a few things that do it in your environment, you could add those to an allow list and say, if anything besides X, Y, and Z runs this command, let me know, because it could be a defense evasion technique. So I'm going to go back to my presentation here. Maybe. And review what we talked about. So we had 4 tests we ran. We had rundll32, which I was calling MS-HTML DLL with an ordinal number, which is just run HTML application. And through some funny business here, there's a whole blog post in the description you can read if you want to understand how this really worked. But through this funny business, it ends up having MS-HTML call another DLL script object and run this script to run an executable. In the next one, we used advpack DLL to launch an INF and just another version, the IE advpack, and then desk.cpl, the control panel DLL, to install a screensaver. So all techniques that are a bit unusual, but have been seen in the wild being used maliciously for defense evasion. So our defensive thoughts should be something along the lines of, how often does Rundll32 even connect to the internet? Is that a normal thing? Because we saw that Rundll32 running an INF file, which in turn downloads code from the internet to run. We should know if that's normal in our environment for Rundll32. If it's not, but there are a few things doing it that are legitimate, we could add those to an allow list. Also, how often does Rundll32 actually spawn a child process? And with that child process maybe not being signed or trusted, that seems unusual. That's something we could keep an eye on. And also, how often does Rundll32 normally load something like script object DLL, or how often does it write to disk? So really, the long and short of the story is, we want to look at the baseline of how Rundll32 is used and what processes call Rundll32 with certain DLLs, and then alert for anything outside of the norm, so that we can investigate this unusual usage and find these defensive evasion techniques. So the moral of the story is that AV might not be as strong as you think. We saw how it was looking for the word bandit. It was looking for the run HTML application on the command line, but that can be swapped out. So that's why it's important to look at the normal behavior for our system executables. This is one of the atomic spotlights in a series of now 5 atomic spotlights going over various attack techniques from MITRE using the Atomic Red Team Library of Scripted Attacks. You can find the rest of the videos and future videos on Antisyphon Training YouTube on their playlist, Atomic Spotlights with Carrie Roberts. If you want to learn more about Atomic Red Team, about attack emulation tools, including Atomic Red Team, Caldera, Vector, and Prelude Operator, you can also look into my 2-day, 16-hour class from Antisyphon Training. I think that Ryan posted links to that there. Thanks for joining us, and that's all I got for today.
All right. That was awesome. You know, people love it when nothing goes perfect, because nothing ever goes perfectly. There's always some troubleshooting involved.
We got it done.
Yes, indeed. I copied the link to the class in the chat. It looks like some of the comments are not getting routed through YouTube today for some reason, but you can find that on the website. Just give it a search. I'll bring up the lower third.
I saw some comments suggesting the use of Windows Terminal app. Yes, totally. That would be a great idea. And I'm considering that for my class. I just haven't done it yet because it doesn't come on Windows by default. But it's so handy and useful. It makes sense to just install it and use it. And especially for demos, it'd be way nicer. Good point.
Mm-hmm. What about the question about the screensaver window showing up during the test?
I didn't see that one.
I'll bring it up here.
Oh, is there some way to do it without showing the screensaver window? I didn't remember, but sounds like when we run it, something pops up and kind of makes it obvious that it happened. I'm not sure on that one. I'd have to look into that more. But some of those other ones, I'm pretty sure WScript shell, the ones that use WScript shell, you can pass in like a parameter that says keep it hidden. But that would be a good thing to add to those tests as well. Any other questions? Not too many comments there. So it looks like we're good.
Thanks for hosting us. Oh, the dog says we're done. All right, we're going to wrap it up then. Thanks for joining us with this AASLR. We'll be back again with Carrie in the future. And I'll probably, I should say, tomorrow we're going to do something a little different with our AASLR. We're going to run a special pilot show of, I'm not going to give too much away. It's going to be something special. You'll see details for it later. It's kind of like a game show thing, sort of. So look to that. It should be fun. But thanks again. And I am now going to kill it with fire. Bye, everybody.